Roberval became professor of mathematics at the Collège de France in Paris in 1632, a post he held for the rest of his life. One reason for his secrecy, and why he didn't publish many of his results, was the fact that he had to compete for his post every 3 years. So his original methods he kept to himself. A famous problem of the time on which Roberval worked concerned the nature of the curve called a cycloid. A cycloid is formed by following a point on the circumference of a rolling circle. It's an elegant curve and was often used by architects. This is the Ponte di Mezzo in Pisa. Built by pupils of Galileo, it has cycloidal arches. But despite the elegance of the cycloid, little was known of its properties. For example, could it be that one of its arches was no more than half an ellipse? Another outstanding problem was to find the area under a cycloid. To solve this problem, Roberval cleverly exploited a technique using indivisibles. First, he considers only half the cycloid. He now sets about finding this area. This curve is generated by half a revolution of a circle. So Roberval divides the generating circle in half. What he's going to do next is subtract the area of the semicircle from the cycloid. The indivisible concept of area means considering the area of the semicircle as if made up of horizontal parallel lines. To subtract the area of the semicircle, each line is moved parallel to itself inside the half cycloid. The area of the half cycloid is now divided into two parts. The shaded part is equal to the area of the semicircle. That's a half pi r squared. Now Roberval has to find this area. By another clever indivisible argument, he shows that if you take a copy of this shape and turn it over, then it fits exactly with the original to form a rectangle. The area of this rectangle is easy to work out. Its height is the diameter of the generating circle, and its width is half the circumference of the circle. So the area of the rectangle is 2 pi r squared. So the area of half of the rectangle is pi r squared. That gives the area under half an arch of the cycloid to be a half pi r squared plus pi r squared, which is 3 over 2 pi r squared. So the area under one arch of the cycloid is twice this. That's 3 pi r squared. In other words, the area under one arch of the cycloid is 3 times the area of the generating circle. Roberval had many ingenious methods like this for solving problems on areas of curves and for finding tangents, but alas, he kept them secret.